have an image. Do we have sound? Yes, we have sound. Do we have an image? Oh, we almost have an image. Yeah, there we go. That's a full stack. That's what I mean by fuller stack, okay? Right, so good afternoon. It's Friday. It's the end. Have you enjoyed yourselves? Really? Come on, let's try that one again. Let me, where was I? It's Friday. It's the end of the week, whatever I said before. Did you enjoy yourselves? Okay, good. Good, I need to know that you're there. I mean, I spend enough time on Zoom. The whole point of the real world is you're like fully three-dimensional. And I'm actually going to borrow a couple of ideas from Pella's talk. One, he said, open your eyes to the world. That's one of the things I want you to do here. Because although many people say, oh, full stack development, it's just like, actually, it's a really tiny piece of the world. And use real life physics. I'm going to do some of that. So my name's Kevlin Henney. I work for myself. I consult, I train, I write. I stare at a screen for a long time. Sometimes things happen. And this causes me to reflect on a number of the things that we have in terms of trends and also our vocabulary. So obviously, I thought, okay, let's look up full stack. What do we mean by this expression, given that I'm going to build full stack 676 results? A couple of hundred of whom I presume are here. But what do we mean by this? And it's just like, it's such a curious term. And it turns out that you need to be passionate. I don't know if that's a way of making more full stack engineers. I would suggest that that's good long-term thinking. But sometimes when we use the term full stack, it's just kind of like, it's a fancy way of saying JavaScript programmer. I was reminded of this graphic just 2 days ago by Hannah Slovert, who said, this is great, I love this, because you get to piss off 2 language communities at the same time. But what I want to do is explore what we mean by this merger of terminology. What we've ended up with is a particular terminology where people talk about front end and back end. And if you're not careful, you end up with an us and them. It's very easy to end up with an us and them, a confrontational situation. So we kind of combine this, we call it full stack development. The problem is, that's not where I'm from. My background is in this bit. I started my career as a systems programmer, factory automation. I don't tend to do device driver stuff, although I have done device driver stuff. Infrastructure, middleware, systems programming. So for a lot of people, when they say full stack, I'm kind of going like, oh, you're all the way up there. Yeah, I'm down here in the full stack. But then there's another point of view. And I want to embrace both of these. There's another point of view that is that which occurs above and outside and around. It is the world around the stack. So the curious thing is we end up hitting the world in both directions. If you keep on going down, you hit mathematics and physics. If you keep on going up, you hit the same thing. And I'm very interested in that because that gives us a context for our work. So this idea is that we need to be a little more aware of the things around us, not just the frameworks, but the dependencies of the dependencies. We also need to understand that that somewhere out there is a human being, possibly more than one, who is working or using your product. But when we start looking at this, we need a kind of system of classification for understanding our code. And most good ideas that we've had come from the past. So I'm going to go back to 1980 here. Meyer Manny Lehman wrote this amazing paper, Programs, Life Cycles, and Laws of Software Evolution. I kind of read it many, many years ago, forgot about it, and then kind of rediscovered it about 6 or 7 years ago. And in it, he offers us a really interesting way of classifying our code and our systems. S programs, P programs, E programs. S is for specification. It means that we can fully specify what we're trying to do. Okay? It is knowable, and therefore it is also testable. This applies to FizzBuzz, sorting algorithms, accountancy systems for which there are international regulations. These are all knowable. If you tell me this is what this system does, I can test, demonstrate this is what this system does. These are kind of they range from the simpler problems that we introduce people to when they develop to larger systems that are composed of this. The point here is these are very knowable, these are very testable. I'm not saying they're completely predictable, but we have a lot of control over them. The problem is, for some reason, we're not very good at getting this stuff right. So that's a credit card number. It's actually the MasterCard test number. And I've entered it there in the way that I normally do. It's 2022, and half the sites I use still tell me that apparently these things which contain spaces, when I look at my physical card, are not allowed to contain spaces. This is an S-shaped problem. I first complained about it in the late 1990s. Apparently, we don't know how to program to remove spaces. I suggest that that's the first, next time you're doing an interview. And that what I love is the fact that somebody's actually gone, and this is the joy of developers, is rather than thinking, how do human beings use our product? They think, it's a 16-digit number, you're not allowed spaces. I will put a space detector in there. I will write code to detect that you have put spaces and put up an error message. That takes more code than doing it right. And then we have blind spots, things that apparently I thought we knew. So I came to Belgium on the Eurostar. Eurostar started service in 1994. The web came into existence a couple of years before that. In the UK, the National Rail website did not exist until this century, and the app certainly did not exist until about a decade ago. They do not yet know that there are time zones. This is apparently news to them. Wait till they find out about daylight savings time. This is basic stuff. This is so basic, it should be on page 0. These are S-shaped problems. We haven't even hit the hard stuff yet. Let's look at P programs. P means, well, we don't actually know what the acceptability criteria are, kind of. We can kind of come up with a procedure for how we do it. But the thing is, I can't come up with a specification in advance and say this is exactly what I'm expecting and then test against it. Now, what's interesting is when Lehman wrote this in 1980, he had a few examples, and they didn't quite fit where he was going. We have a lot of examples these days of this stuff. Machine learning is the perfect ground for this. Machine learning, I keep getting asked, how do you test machine learning systems? Well, you run them, and then you see if you like the answer, and if you didn't, then that's not the right answer. In other words, you negotiate both the implementation and the outcome. Whereas with S-shaped things, we already know what the outcome should be. Now, there's clarification, but it's not negotiation in the same way. XKCD, on the money here. This is your machine learning system? Yeah, you pour the data into this big pile of linear algebra, then collect the answers on the other side. What if the answers are wrong? You just stir the pile until they start looking right. Okay? I'm sorry, if anybody here is in machine learning, that I've just given away the secret of the industry. And then we hit E-type systems. Oh, these are interesting. E is for embedded, and I don't mean by embedded systems. Programs that mechanize a human or societal activity. These are a bit different because what it now means is the system is part of the world, and the feedback loop goes back into the system. Now, when Lehman wrote this back in 1980, there weren't that many examples of this. He used air traffic control as an example. Air traffic control, if you think about it, you're an air traffic controller, you look at the screen, you have data on where an aircraft is, you tell the pilot, hey, guess what? The pilot then responds, which causes the position on the system to change. Feedback loop, where the software is now part of the world that it is modeling. These days, it's hard not to create E-type systems. Social media is a classic example. E-type systems are everywhere, and these are way harder than S and P-type systems, but they are composed of S and P-type code. This is the whole point. It's become part of the world. And this is where we really need to start paying attention to the bigger context. This is a wonderful book, which I wish I received commission on, because the number of times I've recommended it and then had people come to me and say, I went and bought that book, is pretty high. I mean, I'd be able to buy at least a couple of beers, you know. 101 Things I Learned in Architecture School by Matthew Frederick. Beautiful book, lovely book, makes you look smart, as in make sure that your friends and colleagues see it. Oh, wow, not just a software developer, intellectual as well. They're into architecture. Beautiful book, applies to pretty much any design-based discipline. About half the advice here, any design-based discipline, that is software. But there's this lovely quote from Eliel Saarinen, a Finnish architect: always design a thing by considering it in its next larger context. We don't always do that. Or, oh, I've got some code, its next larger context is more code. We can do better. And that's where it starts getting kind of interesting. But it also takes us in the opposite direction. John Carmack, the great games programmer, low-level programming is good for the programmer's soul. Sometimes with high-level languages, people kind of think, oh, we didn't need to worry about the low-level details. They look down on the low-level details. I made this quip a while back. JavaScript developers criticizing C for being low-level and idiosyncratic either have a very well-developed sense of irony or none at all. If you're wondering why I'm saying that, I just need to remind you, these are low-level. Yeah, everybody got flashbacks from 2018? The point here is that it's a very low-level language, and we might think, oh, no, but it's high-level. No, it's got the same syntax. It's got new and exciting errors. People actually have competitions about what this will output in JavaScript. Nobody does that for other languages, except possibly C. Will it crash or will it not? Are you feeling lucky? But here's the thing. The universe is built on C. Yeah? It's made out of C. All of these languages and their libraries are still massively influenced. All the infrastructure that's out there. Scratch it, you will find C. That means that it propagates through. As it were, the material science of C influences everything above it. So I'm going to quote from the IEEE standard, the POSIX standard, and you're going to wonder, why am I quoting from the POSIX standard? Well, I've been involved in standardization, so I have a natural disposition towards it, but in particular, I want to talk about time. Time function shall return the value of time in seconds since the epoch. Notice epoch gets a big capital letter. That's really important. The beginning of time. When was the beginning of time? Well, all you have to do is stick around and wait a while, and you'll find an error that tells you when the beginning of time was. Oh, look, apparently Intel were issuing updates over the web on the 1st of January 1970. I don't think they were. But if you end up with a 0 in the time field, that's when it takes you. That's the beginning of time. I feel kind of smug, actually, because I've worked out if I can live to 2038, there's the year 2038 problem, I think I've got a reasonable chance of living to 2038. If I live to 2038, which is the end of 32-bit time, I will be immortal, because I will have existed before time, and I will continue existing after time, okay? But, you know, feel free to invite me back in a few years, and we'll just see how that's going. Right, why am I telling you this? Because guess what? A few years ago, I decided to submit a bug report to Facebook, back before they were destroying democracy. And I took this screenshot of their response. Your feedback will be used to improve Facebook. Empirically, I now know this to be false. Thanks for taking the time to make a report. How much time? 31st of December, 1969. Whoa, these guys have got a time machine. That's awesome. But that's suspiciously close to the beginning of time. And I kind of had various theories about it, and eventually I realized it's not far into 31st of December 1969. Actually, this is how we do it. We dig out the C standard, and we read through it. The value -1 is returned if the calendar time is not available. And 1 second to midnight is still the 1960s. So wait a minute, hang on. The time is not available. But everybody programs as if time is always available. You know, I call a function, I create an object, and there it gives me the time. How can time not be available? Surely it kind of runs through the fabric of, you know, everything. Yeah, you kind of need to rethink that. We're really bad at spotting error modes. because the real world is a little unkind to us. Our software can be wrong for a number of reasons, but it turns out that our software interacts with the real world. It turns out that you can't assume everything is an S-shaped, closed thing. There are things that are not under your control, like time. So, from the totally awesome 2014 film Interstellar, Anne Hathaway plays the part of Dr. Amelia Brand, and she makes the observation that we need to think of time as a resource. And the one thing we know about resources is they are fallible. They do not always work. Now, it may have been your experience that, oh yeah, every time I call for time, time is always there. But I said earlier on, I've worked in embedded environments. Guess what? Time is not always there. Or, even more confusingly, you have multiple choices of time because you have different clock devices. So when you say, what time is it? Well, what time would you like it to be? Which clock would you like to use? You need to think of it as a resource, as if it were a network connection. This is fallible. It can fail. Now, when we talk about JavaScript, probably a lot of people think JavaScript invented the idea of not a number. This is not correct. It comes from another standard, IEEE 754 or IEC 559, the 1980s. But Java helped popularize it. We have this magnificent intellectual insight from Lufthansa. I tried to parse it, but, nan is not a number. You're right, it isn't. But that's probably not what you were trying to say. We are constantly surprised that things don't work. To be a software developer is to be an optimist. Yeah, it'll work this time, in spite of all the evidence that it won't. You've spent years in this profession, and you still think it's going to work, and it's all going to go according to plan. You're an optimist. But this is frustrating. This is a little more worrying, though, because the real world starts intruding. It's back in 2020. Driverless race car drives straight into a wall. During the initialization lap, something happened which apparently caused the steering control signal to go to nan, and subsequently the steering locked to the maximum value to the right. Oops. That's not good. I mean, good it was driverless, but if you're thinking about, self-driving cars, you need to think a little bit, oh, well, maybe not just yet. We need to get a bit better at this. It didn't actually use JavaScript, it was using MATLAB, which actually doesn't make me feel much better. We seem to struggle with understanding the state model, and we oversimplify things. And we gloss over some of the differences. You've probably all had this experience. You go to a page, it's just like, the number of times I open up an app or a page, and my heart skips a beat, which is like, where's my things? Where's my money? Where's my orders? I actually had it, I was at the Refactor conference yesterday. It has a ticket in Eventbrite. I opened up Eventbrite, you have 0 orders. A moment later, you have 1. This is because somebody is thinking about this in terms of code, not in terms of how to model the world. They've got a little list, and that list is empty, and they're showing the content of that list. But empty is not the same as not available. Or, could you wait a moment? This is the kind of fundamental idea. John Carmack, again, a large fraction of the flaws in software development are due to programmers not fully understanding all the possible states their code may execute in. Developers are constantly surprised. Developers very rarely do state modeling. I see a lot of entity modeling, a bit of object modeling. I see a lot of people focused on the objects, but states are actually the thing that frustrate us in the world. When you walk into a door that didn't open in time. The state of the door is closed. The state of your nose is bruised. We are often confounded and surprised by states. And it actually turns out that's the blind spot that we have in here as well as in our languages. And you've got to really think about this one. That's what you want. Empty is not the same as we are getting the data. And I see this everywhere. And it's a really obvious thing is that people think, oh, it's just an implementation detail. It's not. It's a model of the world. Now, this whole point about latency is an interesting one because it turns out that you've got to use real physics. I'm going to borrow from Pelastors. You've got to respect the fact that although ideally when we write code, we think of everything as instantaneous. So just in time, it turns out that one of the things I'm known for is that people send me error messages, and I just retweet them. Oh, by the way, that National Rail one I mentioned earlier on, National Rail got in touch with me and said, would you like to submit a bug report? You know, it's just, I'm thinking, really, it's you guys that need to learn about time zones, but sure, I'll submit a bug report. I did. I just posted the link to my tweet. We'll come back to links and levels of indirection in a moment. And I busily prepared yesterday a beautiful picture of a map of the Atlantic so I could make a point. And then Martin Fowler tweeted at me that with a map of the Atlantic, and it's perfect. I'm going to use this instead. You ought to know that United may have discovered a kink in the space-time continuum over the Atlantic. Destination time, 0, but the distance to travel is not 0. Sadly, they weren't able to take advantage of it and get me home earlier. Okay, let's look at this. So, there is physical displacement between Heathrow and Newark Airport. I'm going to use that as a proxy for North America and Europe. When somebody says, you know, we have servers in North America and in Europe, and we would like the data to never be more than 10 milliseconds different. We need synchronization within 10 milliseconds. What you need to know is that that's not 20 centimeters, that's 20 light milliseconds. If somebody asks you, we need this to happen in this time frame, and it would violate the laws of physics, it's not negotiable. Okay? You will never be better than 20 milliseconds. But it also turns out that actually you're not going to get 20 milliseconds either. Yeah, electrons and software and hardware all get in the way. So there's a real issue here. You have to respect the physics, and that changes systems. But then when we scratch mathematical possibilities, we also find other limits. There are boundaries to what are possible. So back in 1931, it's a translation of Gödel's paper on formally undecidable propositions of Principia Mathematica and related systems. It's one of those kind of like snappy titles. Basically, Adrian Collier's morning papers, he did this wonderful summary about the vision that existed. At the end of the 19th century, beginning of the 20th century, there was this vision that everything was kind of like either solved or about to be solved. We were on the cusp of solving everything. Everything was knowable. Everything was knowable. Logic, oh yeah, we're going to unify logic, mathematics. We're going to prove that mathematics is consistent and it's complete. Physics, oh, we're practically there, you know? Oh, there's that funny relativity stuff, but that kind of fits. There's nothing else that's going to surprise us. Oh boy, they were in for such a shock. The 1920s and 1930s were not kind to this vision. In particular, in 1931, Kurt Gödel came up with 2 incompleteness theorems in his paper, which basically showed what he's actually trying to say is wherever you have a consistent axiomatic system, anything that can be reduced to mathematics, I don't like to think of programming as mathematics, but it can be formalized. It basically means that you will never be able to demonstrate that there are certain things that are true in that system that can be proven as true within that system. You can only prove them by stepping outside the system going, oh, that's interesting. By the way, at this point, you're in a different system. You will also have things that you cannot prove to be true from within that system. It's turtles all the way down, or up, depending on which way we want to take this. Now, why is this relevant? Well, there are a few issues that we sometimes hit in code, but I'm not going to do those. The one that Adrian picks on is another one, which is interesting. I mentioned machine learning, kind of throwaway comment. I'm going to pick it back up again. One premise of many models of fairness in machine learning is that you can prove the fairness of a machine learning model from within the system, from the properties of the model itself and the data it is trained on. This is known to be false. This is really important because this also falls under the umbrella. So this is not merely a marketing pitch. So this is where we have to start being a little more sensitive to what are people actually saying? Have they just violated something fundamental in the universe? And in many cases, they are. To show that a machine learning model is fair, you need information from outside of the system. If you work on a closed basis, you're going to be in for a nasty shock. Reality has a very different opinion. But you don't even need to go crazy with this stuff. You remember the beginning of the pandemic? Lots of lockdowns, and you're allowed to go out for a walk sometimes. One rather enterprising artist in Berlin, Simon Verkert, decided, as you do, to go and buy 99 second-hand Android phones. And he put them in a cart, and he walked the streets of Berlin, and he created traffic jams. You see, you've got to distinguish between reality and proxy variants or proxy measurements of reality. William James, we must be careful not to confuse data with the abstractions we use to analyze them. It turns out that when Google Maps shows you where a traffic jam is, it doesn't. It shows you where there are lots of phones that are moving relatively slowly. That's what it does. And there's a reasonable probability that's a traffic jam. But it's not a 100% probability. It could be some crazy artist walking the streets. But more importantly, this idea of understanding the thing that we are talking about and the thing that we are actually using to measure the thing that we are talking about are not the same thing. And we often make this mistake. We like simple solutions. We like shortcuts. So here's one that is used a lot in the web space. So much so that people don't even know they're using it. We need to increase engagement. Engagement. What is engagement? Well, when I go and consult the dictionary, I find out that it's the state of being engaged. I would be amazed if your product measured that. I would also be slightly concerned, because that's definitely something that happens up here. You can't do that. You cannot measure engagement. You cannot measure my emotional involvement or commitment. And if you can, then there's some serious violations of GDPR. What you are measuring, reality should always be in quotes. What you are measuring is clicks and shares and time. That's it. You haven't measured engagement. And if you think you've measured engagement, you're in for a nasty shock, because that's not statistically applicable. Correlate it, but be aware that there are bots out there that are hacking this. And be aware of the sensitivity, the brittleness of these numbers. Be very cautious. Those numbers have value, but they might not have the value you thought they did. And when it comes to dealing with forecasting and predicting the future, what I love about this quote, we don't know who said it. I always thought it was Niels Bohr. I co-authored some books on pattern-oriented software architecture a number of years ago, and one of my co-authors, Doug Schmidt, was certain that it was Yogi Berra. And when you're co-authoring a book, you have lots of trade-offs. So he got that one. I was very upset about publishing it with Yogi Berra's name, but that's fine. I got something else in return. It's a trade. But what I like about this is we don't know who said it. When you actually dig through, we don't know who said this, and that was the past. How on earth are you supposed to predict the future when you can't even tell what the past was? And we need to be really cautious about this. And I often talk about this in terms of roadmaps, because people use the roadmap metaphor for their products, for their companies, for their architectures. And if you go online, so this, first year of the pandemic, I'm sitting there going like, yeah, the whole roadmap thing's got out of hand, and I normally draw a whole bunch of roadmap things when I'm running workshops. And I just thought, let's just go and look at roadmap PowerPoint templates. Oh, there's loads. And you know what? Half of them use roads. It's kind of cute. A roadmap with a road. And there's look at text here. You put your text there. So here's where I live, just slightly north of there, top of the A30, or further into the A38. Bristol. This is a roadmap. I was tempted to use a roadmap of Antwerp for this image, but it's far too confusing. This week, I've had 2 people drive me in Antwerp, and both of them got lost, and both were Belgians. I'm sitting there going like, okay, I'm out. If you guys are confused, it does things with space and time that I don't think are accounted for in any theories we have in physics. So I'm going to stick to Bristol, because I know that mostly respects the laws of physics. But what you can tell here is there's more than one road. And if you pause for a moment, you think, oh yeah, that's why we use roadmaps. We don't use roadmaps when there's only one road. People did not invent the idea of a roadmap with one road. That's kind of dumb. That's a list. That's an itinerary. You don't need a roadmap. I'm reminded of a holiday that I went on with my family a couple of years ago. And I'm sitting there with Google Maps, and my wife's saying, there is one road on the island. You have a choice. You go out the house, you go left, or you go right. You will still end up coming back to this house, whichever direction you go. Kevlin, there really is only one road. Yeah, good point. We don't need roadmaps for one road, but you can't predict the future. The whole point of roadmaps is there's multiple roads. Show your team, show your stakeholders the possibilities. That's the value you have. If you give them a vision of the future, it is false. If it's only got one road, show them, say, this is the road that we want to go on. This is the road we like. This is the most likely road. But just like driving with Google Maps, you may find, because of other things, this route is 5 minutes faster. This route becomes blocked. This is a similar path to the same outcome. That's the value of roadmaps. So in other words, I think the roadmap metaphor is fantastic. I just wish people use it correctly. But my favorite thing about predicting the future was this one. Here they put on years. This is you can tell when it starts, 2018. This PowerPoint template is clear from 2018. Meltdown, Spectre, yeah. 2020. Yeah, remember that? And I'm sure you had it in your plan. You know, your company said, oh, by the way, next year's going to, in 2019, you had your Christmas event, 2019, and your CEO said, guess what? Next year's going to be a real fuck-up. There's going to be a global pandemic, and we have no idea anything about it. It's going to mess with the way that we work. It's going to mess with your mental health. It's going to mess with our customers. It's going to basically upend the world. So we put that in the roadmap. No, you don't know the future. That's why you need more than one road. Yeah, you probably still won't have global pandemic on the other ones, but at least you're hinting at the possibility that you don't know everything. This also has consequences for how we talk about our requirements. When we're talking in the real world about the system we're building, there is this rather nice little mantra that has come out of the Agile community, that you prioritize your requirements by business value. I see this a lot. I've been involved with the Agile community for many, many years. There is a small problem with this. You can't do it. Now, I'm going to be very, very clear. I'm not saying you shouldn't do it. You're welcome to try. But it's a little bit like traveling faster than the speed of light. You will not succeed. You cannot prioritize by business value because you do not know what the business value is. The business value will only be known at some point in the future. You cannot prioritize by business value. You can prioritize by estimated business value. That extra word is really, really important. And if somebody says, oh yeah, but Kevlin, you know what we mean? It's the same thing. Then we really need to have a conversation about the difference between estimates and actuals. We shouldn't be at the point we're confusing that. But we also have challenges when we talk about business value. This is not impossible, it just needs to be clear. When we say business value, whose business? Because I've certainly made decisions in the past, in fact, very near the beginning of my career, I made a decision that had high business value for our customer, but not for us. And I was really pleased because I had saved 2 weeks of work, and it meant that we didn't have to extend the contract, and I had made life easier for the customer. My manager was not quite as impressed as I was. Business value. Is it ours? Is it theirs? Oh, by the way, what time frame? Do you mean business value over a week or a year or a quarter or a decade? It turns out these give different answers. So when somebody uses, so a lot of people like say, oh yeah, we're really focused on business value. Just ask them what they mean. Because it turns out the answer, the short-termism, long-termism can be very different between different people. It's a cartoon from Tom Torra in 2015. Yes, the planet got destroyed, but for a beautiful moment in time, we created a lot of value for shareholders. Let us not find ourselves in that. So we're talking about people a lot here, and I happen to regard them as a rather important part of, as it were, the world outside the full stack. And I mentioned the Agile community. There's this manifesto, Gesundheit. It's over 20 years old. And it's not perfect, but actually it's really well written. As a piece of English and structure, it's actually really rather good. We are uncovering better ways of developing software by doing it and helping others do it. We are uncovering. That's the continuous present tense. It suggests an ongoing action that we are never complete with this. We are uncovering and will continue to uncover. Our work is never done. This is the one time you can actually say we don't have to be done. We will always be improving. That is our goal. And then it's a very clear statement of values, which we still struggle with. And this is the problem. This one, we seem to gloss over this one. Since Agile became a thing, individuals and interactions over processes and tools, since Agile became a thing, I see a lot of people talk about processes and tools. You go to a company and say, oh, we're Agile. And then before you know it, they've told you about all the mechanics of their CI/CD pipeline. And oh, yeah, we use Jira and we use this. That's a lot of tools. And we're doing Scrum, and we're doing this, and we're doing that, and we've a bit of Kanban sprinkled on the top. Yeah, but what about the people? That's where the magic happens. That's who's creating this, but it's also where the ideas come from, and ultimately, who it's for. So there's a little weakness there, and we need to understand this a lot better than we do. Because, as it were, software development is a team sport. It's a kind of collective intelligence exercise. There are very few systems that are created by individual programmers. We need individual skill, but it turns out that team skill and team dynamics are the other side of it, the interactions. Biggest advantage of autonomously working teams is risk reduction through increased group intelligence. I was on a good day when I did that interview. That's a great quote. I mean, I know I said it, but I'm not sure I could say it now except by reading what I said in the past. But more importantly, when we start regarding it as an activity of group intelligence, because this is the whole thing. You're trying to solve hard problems. Software development is one of the most creative things that humans do. It's also surprisingly hard because we're dealing with the interaction between an informal system, human beings, and a rigidly formal system. And we are the interface. Bridging these two worlds is a challenge. It's exciting, but it's also frustrating. And we also need to be very, very aware that getting a bunch of people who are individually smart together does not guarantee collective intelligence. If a group includes more women, its collective intelligence rises. Now, I suspect some of you knew that, but from what I can see, it's a minority of you. You need to tell the others. Okay, this is a paper that's like over 10 years old. And this is a really interesting one, because what we're actually talking about here is, actually, by the way, ever since I discovered this, I changed the way that I do workshops. I don't want to give teams an unfair advantage. So it's nope, no, I'm sorry, I'm going to have to move one of the women over there, because otherwise you guys are just going to have to perform these guys, you know. And I'm not wrong in that, I've discovered. But the point is, what you're actually doing is it's not a male-female thing. It's actually much, much broader. What you're doing is you are changing the way that a group thinks. Because if you all think the same, then you're not thinking. I did work for a number of companies where they've had the same recruitment policy, and people have a real habit of recruiting in their own image. It's a really strong habit. It's safe. It feels safe. But the danger is that you end up with more people like you, and you might think, well, yeah, I'm pretty good. Okay, I'm going to have to take you down a notch a moment. Maybe you are pretty good. I'm sure you're awesome. But other people are differently awesome. And it's kind of like you kind of need that variety, because you don't want more people thinking like you, because if you think like this and the problem you're dealing with is like this, you're not thinking big enough. You need more things. You need more insights. You need people going, wait a minute, haven't we overlooked a case? Didn't this happen like 30 years ago? I wasn't even born 30 years ago. Yeah, that's why I'm saying it. That's the point. You need all of this. Different backgrounds, different educational backgrounds. You don't want everybody. I visited a company that thought they were really liberalizing their recruitment strategy by saying, well, we've discovered we've got a bit of a problem. We're always recruiting computer scientists, and we've kind of hit a wall. So we're really branching out by recruiting mathematicians and physicists as well. And I kind of looked at them and said, there's a few other subjects out there as well. You know, consider a linguist, perhaps, or a historian. It turns out people with different backgrounds have a completely different way of framing the world. It's fantastic. So you just look at things differently. Now, this is all part of this kind of idea of group intelligence. There's a book from 2003, James Surowiecki, The Wisdom of Crowds, where he looked at this, and he established 4 criteria for wise crowds, as opposed to groupthink. Okay? That's the other thing you get. When you get lots of people together, well, in Britain we call it Parliament, you can end up with a very stupid group, much, much dimmer than the individual intelligence. But what characterizes a wise crowd? You can't all, diversity of opinion. You can't all be saying the same thing. Independence, you must be able to think separately. That's actually surprisingly hard to do. We are social animals. But that is enhanced by the idea of decentralization, that we draw on different sources. Our backgrounds are different. Therefore, we do have a bias in that direction. Oh, but by the way, it's no good doing all of this unless you put it all back together again. Aggregation. Now, aggregation, there are many constructs for aggregation. Meetings, they might not be the most efficient, but that's an aggregation construct. Slack, again, if you ever wonder, what shall I do with the gigabytes of memory that I have available, Slack will answer your question. All your memory belong to us. But the code base is also an aggregation mechanism. The code base is a social space where we collectively create a construct, a place where we live. That's why we call it architecture, okay? You are creating a social space in which you are coming together saying, this is how we bring the technology together with the business and our knowledge of these things and our own experience. It's a space where we work. It's a very virtual space. It's slightly more exciting than Zoom. In fact, it's a lot more exciting than Zoom. But it's an aggregation mechanism. It's where you're bringing these things together. It's a social construct. So it tells us that our values need to be a little bit different when we start thinking about people. We often talk about the 10x developer, but it turns out helping other people is how you get that. It's a multiplier effect. So we need to be really careful about some of the snake oil that's going around. Okay, it's at this point I've realized that I am an independent consultant, and therefore I get to say what I want because I don't work for a company. So let me start by quoting Voltaire. Back in the late 18th century, this body, which was called, and which still calls itself the Holy Roman Empire, but was to be dissolved within a couple of decades after that, was in no way holy, nor Roman, nor an empire. Why am I telling you this? Because I believe the same is true of the scaled agile framework. It is in no way scaled, nor agile, nor a framework. And it's certainly not safe. We have an obsession with this stuff. And this idea of scale, bigger is better unless you're out fishing. A friend of mine, Alan Kelly, made this wonderful observation. Software development does not have economies of scale. It has diseconomies of scale. It's the opposite. When we talk about scaling, we have this really bad habit of assuming by default that scaling is up. But scaling has two directions. In fact, some domains and disciplines actually use the word scale the opposite way. As I discovered when my older son was into CrossFit, it turns out they use the terminology scaling. You scale an exercise, but what does it mean? If you're not as fit as you were or you've sustained an injury, to scale an exercise means you scale it down so you can still do the repetitions, but it is not necessarily as hard. So in CrossFit, scale means down. So when somebody says we need to scale this development, your answer should always be yes, followed by a question. Do you mean up or down? That should normally be enough to slow people down. Now, when we talk about scaling, I want to go back to computers from people. We need to kind of also recognize that many of these issues pop out in the very systems we create. Distributed systems. Often people do things on, sometimes they add threads, they add cores, they add machines. There are lots of reasons we distribute. Sometimes they're naturally geographic. I want data in my hand, but that data is somewhere else. Therefore, I've got a phone, and there's a server somewhere out there doing work in the cloud, somebody else's computer. We are distributed by definition, but sometimes we distribute for improved performance. We do it for security reasons. There's lots of different things. So there's some interesting consequences to this. This is an interesting one. This was a couple of years ago. Fires in California are really very popular at the moment. In fact, every year, so I kind of forgotten what year this was. But there was this interesting thing. Fire in California, you can't read your ebook in Pennsylvania. We end up with this rather curious non-local effect, that the things we thought were ours, that's my ebook, I can't read it. It redefines the concept of possession. Perhaps the idea of possession and property are not quite what we thought they were. Or rather, perhaps they don't translate into the digital realm. We're also helped on this by Brewer's theorem, which is probably better known as CAP theorem. It's originally a conjecture, but it's been proven to be a theorem. CAP theorem. So just quick show of hands. Who's heard of CAP theorem? Okay, a handful of you. So I ended up in conversation over dinner a couple of nights ago, and three of us, software, one of us is not. Anita Sengupta. She's a professor of astronautics, which quite frankly is the coolest job title you can have. So she's like hardcore geek, but she's not a programmer. And she's not heard of any of this stuff. But she's also very into cats. So she said, wait a minute, cat theorem? And we said, well, no, CAP, C-A-P. I'll come back to the cats in a minute. So what's this? Consistency, availability, partition, tolerance. Eric Brewer established that what we've got here is you've got these three things that you might want in a distributed system. Consistency. Whenever we ask for a value, we will get whatever node, whether we're talking about caching or anything like that, wherever you ask, you get the same value. It is consistent. Or you get a failure saying that value is not available. I cannot fulfill this request. So you get it's either going to be the same, it's either going to be consistent value, doesn't matter who you ask, or you don't get an answer. Availability says you will always get an answer, but we can't guarantee it will be up to date. We can't guarantee it'll be the same if you ask elsewhere. Partition tolerance is perhaps the least helpful term. Partition tolerance, when your network becomes two networks. Basically, a router goes down, a server goes down. Basically, something crashes. And this also, by the way, led to the realization when I was explaining it to her. She said, but tolerance, Kevlin. So after Anita Sengupta, we do actually have the CAT theorem as a result. But let's stick with CAT for a moment. So the point here, as you can tell, it's a hard ask to get all three of these at once. In fact, it's so hard that it's not possible. That's why it's a theorem. You can have any two. You will always get the right value. The system will, or you'll get a failure, but the system will continue running. In other words, if there is a crash, if there is a failure, we will still be running. It doesn't take everything down. Or we'll give you the best answer we've got, but I can't guarantee it's going to be consistent with anybody else's, but we're not going to give you any failures. Awesome. That's how we do resilience. That's the classic example of caching. Or there's this rather interesting edge case where we can actually guarantee you will always have the right answer and it will always be available except when everything crashes. You might say that's not very useful, but actually it's a single process or single thread case. It's an edge case. Now, this has some really interesting consequences. I mean, first of all, it tells us that we have limits to knowability. Hitchhiker's Guide to the Galaxy, in it, there is this wonderful statement that we demand rigidly defined areas of doubt and uncertainty. And we have achieved that. We have a Heisenberg uncertainty principle for the network. There is a limit to our knowledge. We cannot know everything. There are these three qualities. You get to choose two. Now, does that have any other consequences? Yeah, so this is the wave equation for Schrödinger's cat, which I won't explain. And obviously, when Schrödinger talked about this, he didn't have the access to emoji, so I've somewhat simplified it here. The cat is dead and alive. But what it tells us is that we sometimes live with these paradoxes. But we don't need quantum mechanics for this. Here's one. I get this one a lot as well. Probably not as much as the heart stopping, oh my God, where's my stuff? Oh, there it is. But I get this a lot. You have two orders, 1, 2, 3. I've even had somebody say, oh, but Kevlin, that's eventual consistency. No, that's total bollocks. That's not eventual consistency. That answer is wrong. If you're getting the 2 from a database over there and you're getting the 3 from a database over there, what is the correct answer? There is only one correct answer. It is you have 3 orders because you just showed me 3. Don't tell me I have 2 and then show me 3. You've got to be, as I noted here, you can have eventual consistency in the network, but when you're not in the network, in other words, you are in the client, in one space, in the same address space, there is only one answer. If you don't get that answer, that's called a bug. That's nothing to do with eventual consistency. Don't blame the network. But there are some interesting consequences also for our economics and our digital fetishes, for want of a better term. NFTs, non-fungible tokens, had to be said at some point. Fungible, it means that something's interchangeable. That's the intrinsic nature of digital technology. For something to be non-fungible is actually against the nature of software and the digital realm. It means that everything is substitutable. If I've got a JPEG and I give you a copy of the JPEG, then you've got a copy of the JPEG that is indistinguishable from mine. Your digital asset is identical to mine. The property metaphor that comes from the real world does not work in the digital realm. It took blockchain to try and make it even vaguely real. Now, non-fungible tokens, there's a whole load of stuff about those, which I'm not going to go into, but they are based on the blockchain idea. And you heard it here first. The blockchain is an irrevocable, shared, distributed database of transactions. That has certain uses. We're actually going to see it coming in next month. The ISO 20022 standard is actually basically going to be kind of enhancing SWIFT and other international payment mechanisms using blockchain. But what's interesting is that's not a decentralized kind of system. That's actually an internationally agreed upon system with ultimately a centralized authority. No, the thing that we've got to watch out for is some of the snake oil that goes with this one. I mean, obviously there's the power consumption stuff that comes with proof of work. And there's all of that, and that still is a bit of an issue. But the thing I want to focus on, specifically not to do with cryptocurrencies, is actually what we're talking about with NFTs. So seeing as I'm here in Belgium, here is a famous painting by Magritte. But actually it's not, is it? Because the whole point is that this is a photograph of the painting. And the painting itself is an observation that that is not a pipe. It is a picture of a pipe. When you buy an NFT, that's what you bought. You bought the photograph of the picture of the thing that is not the thing. You bought if anything, well, if you want a better metaphor, you've got a photograph of the receipt for something, but you don't have the something. Because the something is typically a digital asset. And that digital asset, what happens? The NFT is associated with a reference which points to something else that is completely fungible. This is fungible, okay? I can give you the bits to this. I got them off the internet, France TV info. It turns out that all you've done is you've bought a unique receipt, photograph of a receipt. Well done. But there's something else here as well. NFTs rely on consistency, that we all agree that I have this that this is true, that I have this artifact, this digital artifact. And that information is available, because otherwise it's not a possession. And that it's also fault tolerant, because otherwise it's not a possession. You see, there's a small problem with NFTs, is they rely on cat theorem being false. And that's not going to work. So I'm going to end this right here, because what I wanted to focus on is the fact that when we talk about the full stack, we throw that around as a shorthand for front and back end. We need to recognize it goes all the way down, but more importantly, all the way up and out. It embraces the real world with all of its strange and glorious people and all of its weird and funky mathematics. And it turns out that if you are developing in contradiction to that, you can only sustain that contradiction for a certain amount of time before the real world comes to get you. And it will. Thank you very much.
Thank you very much, Kevlin.